I'm assuming that these 36 slots are equally likely. So the probability that you win when rounded to 4 places, win, i.e. get $35, is going to be that. Whereas the other 35, you would lose. And so, $1. There are 38 slots. Okay, so let's try 0.0263. And 0.9734. .9737. Okay. Determine the mean and standard deviation. Seems like this is going back to a previous chapter. So let's clear out this data. Looks like we've got a discrete random variable here, 35, -1, probabilities of 0.0283 and 0.9737. So multiply those two. Oh. List 1 times list 2. And we're going to need our sum of list 3. To get the mean. That's 0.0168. But that would round to 0.02. And then sigma, I'm going to do that without the rounding, take 0.0168. Scores in list 1. List 1. Minus that mean. Square all that and multiply by the probabilities in list 2. The sum will be of list 4 will be our variance, and our standard deviation will be the square root of that. I'm going to go to second stat and math to get the sum of what is in list 4. That would round to 5.97. Make sure that's I entered things correctly. That explains it right there. That was 0.0263. And unfortunately, I'll have to start that from the beginning then. List 1 times list 2. Sum of that will give us sum of what's in list 3. Will give us the mean. Okay, to the nearest penny, negative 0.05. Kind of makes sense. Lose more often, greater chance of losing. And without the rounding, negative 0.0532. Clear that out. Score in list 1. Minus a negative, it's going to be the same as adding a positive. Times the probabilities in list 2. And now I should be able to repeat this. 5.76. Okay. See what else is going on here. Suppose you play the game 100 times so that n equals 100. We should have, because of that large sample size, the sampling distribution of x bar should be approximately normal, with a mean of negative 0.05. But the standard deviation, you would take sigma and divide by the square root of the sample size, 100. Square root of 100 is 10, so 0.576. That would round to the nearest penny to 0.58. What's the probability of X measuring how much money is received? Received if positive, you receive a negative, it's actually a lost. What's the probability X is greater than 0? Okay, so score minus mean divided by standard deviation. 76 was divided by the square root of 100. That z-score will round to 0.09. Apply symmetry, look up negative 0.09 so that we have less than the way the table is set up. Right now, this is set up for x being greater than positive 0.09 for z-score. If I apply symmetry, that would equal the probability that z is less than negative 0.09. It's going to be in the last column. 0.4641. If you do this 200 times, now I'll be looking up again. We have probability x bar is greater than 0. So the probability z is greater than 0.12. That probability would equal the probability z is less than negative 0.12. So that's going to be in the third column. Negative 0.12, getting 0.4522. You played 1,000 times. Round that to 0.27. And again, with the symmetry, I'll look up negative 0.27 because of the direction this is going. It's going to be in the third column from the left, from the right, I mean. Oh, you can see it on the bottom. Negative 0.27, 0.3936. Those probabilities went down as the sample size went up. The probability of a head, i.e. greater than 0, decreases as the number of games played increases. Okay, that's all I've got for now. Hope this helps.